So, today we are going to be testing the absorbency of two materials. The first is a microcloth synthetic. I'm skeptical as to how absorbent it is. They claim it's really absorbent. Then we have a standard cotton dish rag, which by experience is more absorbent. So, let's figure out how what the dimensions are. Have a 20 centimeter ruler. Don't know if you can see that. 20 centimeters. Looks like it might be backwards. 20 centimeters. We're going to measure this. And that looks like it is 25. Writing it down on this little sheet of paper over here. Sorry. 25 by. Mark the spot. 27. There you go. 25 by 27. Now, the calculator on this thing is dysfunctional, so we're not going to use it. So we have another calculator, which is functional. 25 times 27. 675. That makes sense, right? Okay. Yeah, that makes sense. 675. Makes sense. 25 times 25 is 625, so add another 225s, that's 675. Okay. So, that's the dish rag. Now for this one. It's bigger, that's why we are, you see it's clearly bigger. That's why we're measuring them. It's going to be slightly harder to measure since it's curling, not woven particularly well. So, clearly much more than 20 centimeters. Now it looks like 38 and a half. That's an annoying number. 38.5 by hopefully this comes out to be an even number. That way we end up with a whole number by 37. At least we don't have another decimal. 38 and a half times 37. Clear? Why isn't this clearing? There we go. Okay. 38.5 times 37. That didn't work. 38.5 times 37. Take 2. That's more reasonable. Off by a factor of 10 last time. 1,424.5. Now I'm just going to ignore the 5 because it doesn't matter and change the 4 to a 5. Round up. So we have 1,425 square centimeters. So now we have how many square centimeters each of these has. Now, I have 2 of these bowls. 1, 2. And I'm going to put the dish rag in one of them. Oh, they don't have any water in them. Except for this one has a small amount, but you can see it didn't like dump all over the place. So that one's got a small amount. Dish rag. Microcloth. Boom. So, now we have to fill these things up. So, I'm going to fill them up. So here we are again. We're gonna fill this up, this little measuring cup, up to 500 milliliters. Close enough. 500 milliliters. Now, I'm gonna go dump this in the first one. And now we're gonna do it again. And I'm gonna dump this one in the second one. So, we have a lot more extra room in those two bowls. So, I'm gonna put another 500 milliliters in each one. Another 500 milliliters into the first one. And that's ounces. Yet again, another 500 milliliters into the second one. So you can see that I have about the same amount in each. This is the one that has a larger area, so it's really no wonder that it's taking up more space, there's more displacement. And now you can see already that this one, that they both seem to be about completely saturated. Maybe this one could hold a bit more, except it kind of looks like it's dripping a bunch of stuff that's not really absorbed by it. And then this one is also dripping a lot of stuff that isn't really absorbed by it. So, how about we give it a little bit longer. I won't make you watch the longer. So, I'm going to pause this. So, I gave it an extra about 2 minutes. So, I think now we are ready to figure out how much water is left. That's how we're going to figure out how much was actually absorbed. So, we're going to go back over to the sink. So here is the microcloth. You can see clearly dripping lots. Seems to be fairly saturated. If I submerge it more, it doesn't seem to be soaking up anymore. So I'm gonna hold it like this for until it's not dripping with a constant flow. Actually, I should probably hold it a little more loosely, because it could be argued that I'm squeezing some out. So the one is done, but this one is still flowing steadily. Give it a little bit longer. It's starting to become just drips. There we go. So, dump that in the sink. Get our measuring cup. And extremely scientifically, I am going to pour this in while attempting to spill as little as possible. And fail miserably because I'm terrible at pouring. And I'm going to pour some onto the counter. But nobody saw that. And it's too much in it. Actually, that's not quite true. It's a little less than 900 milliliters. Maybe 880. But I spilled some. So we're going to say it's 900 milliliters left. So it absorbed all of 100 milliliters, 100 cubic centimeters of water, a tenth of a liter. So, first one, over and done with. Dump the water out. So, we have our previous math from before. It's a little sloppy, my handwriting isn't great. So now below the column for that, the microcloth, I'm actually going to label my columns. MC for microcloth and DR for dish rag. You can see that it's on its side, but oh well. And so I'm going to make a little line, squiggly line, below MC. I'm going to write 900 milliliters left. And for under DR in a bit, we're going to record how much that was. So, you see, very sophisticated. Same system for determining when we've got all of it's absorbed as much of the water as it's going to, it's dripped off as much of the water as it's going to. We'll dump it in the other bowl that's in the sink. Think it's good. Actually, we can put the microcloth in that bowl too. Let's do this again. Hopefully, I will spill less this time. I make no promises. Wow, good for me. Didn't spill any. Okay. So, this one absorbed more. Big surprise. It didn't absorb much more. This has 860 milliliters left. So, almost full. But I didn't spill any this time. So we're going to say it was 875. Because that's a nice number, you know. It's always nice to have reasonably nice numbers. We'll say that it's like 875 or 8 and 3/4 deciliters, would it be? Yeah, 8 and 3/4 deciliters. That's a nicer number than 8 and 6/10 or 8 and 3/5 deciliters. So we're gonna write that down. Hopefully my paper doesn't get too saturated. So what was it? It was 875. You see, this is a funny pencil. It's got 2 erasers. Neither of which are dead, actually, magically. So, 875. If that's backwards, I am sorry. Got 875, 900, and then our area in square. So this is in milliliters or cubic centimeters, and this is in square centimeters. So now all we have to do is some calculations. We have all of our numbers. Now we are going to calculate the actual amount that it absorbed. I'm going to dump this. We'll calculate the amount that it absorbed, each of them, and then figure out how much they absorbed per square inch. Because without, per square centimeter, sorry. Because without that we can't really determine how much they absorbed. So, let's go back to where it is drier. Relatively drier anyway, it's still fairly wet. So first we have to figure out how much it actually absorbed. So 1 liter minus 900 milliliters, 1000 minus 900, that's easy, that's 100. And 1000, sorry, minus 875, that's just 125. I almost wrote 175. So we have 125 and 100. That's how much they absorbed individually. So you can see, even without the fact that the one is bigger than the other, it still absorbed more. The dish rag, the cotton dish rag, still absorbed more. So let's do some calculations. Get our calculator back out. Make another little line on the paper. What do we want to do? We want the absorption rate, which we'll do in milliliters per centimeter squared. Milliliters per centimeter squared. So we have our milliliters and our centimeters squared labeled the rows. Milliliters and centimeters squared. So turn on the calculator again and do 100 divided by 1425. That's not a very nice number. 0.070175438. I don't like that number at all. That is a very annoying number. I think I might want this in meters squared. So to convert to meters squared, clear that, we will have to meters squared, put that down. We will have to take what we have, and since it's squared, we have to divide it by 100 squared, which is, well, 10,000. So 675 divided by 1 or 10,000 is 0.0675. And 1,425 divided by 10,000 is 0.14. Put that in the wrong place. 0.1425. Make another little squiggly line. Finally, for our calculations. Now we don't have centimeters squared, we have meters squared. Milliliters per meter squared. clear. So we have 125 divided by 0.0675 gives us, where's our decimal point? What the hell? It just cleared itself. Okay, well, let's do that again. 125 divided by 0.0675 equals. I can't see the decimal point. Ah, there we go. 1,851.85. Let's do 2 decimal places. Sorry, got a little cold. Clear. And now let's do the other one. 100 divided by, divided by 1,400, no, clear. Keep doing that. 100 divided by 0.1425. $701.75. We're going to make a little line separating our 2 columns to make life just a little bit easier. And this is our final milliliters per meters squared. Don't need that anymore. So clearly, the cotton cloth absorbs much more than the synthetic cloth. It absorbs over 1,000, milliliters per meter squared more. I think that's quite a bit more, and a substantial amount. It's enough more that I think microcloths should not be advertising that they are better than the cotton ones, because they're not at all. They're like only a little more than, no, a little less than half as good. It's not better at all. So, all in all, I think we figured out our numbers. A standard dish rag cotton absorbs at a rate of approximately 1,851.85 milliliters per meter squared, and our microcloth absorbs at a rate of 701.75 milliliters per meter squared. Thank you so much for watching.